It's great to be here. It's super intimidating being here with lots of image makers because I'm many things, but that is actually not one of them. In fact, I'm a scientist. And I come from a time-honored European tradition, and so I'm gonna tell you a story. In fact, I'm gonna read you a story. So, I'm part of the cabal of science. And first thing I want to do is tell you a little bit about what we do, about what scientists do. So lots of people think that we geek out in a lab, and lots of us do geek out in a lab. But really at its core, science is about discovery. It's discovering how the world works. Scientists are pretty curious people. We're noodlers. We're sort of perfectionist noodlers. We're the watchmaker's apprentice. We're trying to figure out how the pieces go together to make a working whole. But I think that's really the heart, or really more correctly, the head of science. People trying to peer through patchy morning fog, striving to imagine the entire landscape, and then inventing new tools like new cameras to help them image that reality. So you probably already know that scientists are pretty socially inept people. We're largely shy persons, and we're unfamiliar with the normal social signals that the rest of the world uses. We're not really good at smiling, and we are not good at responding to questions from real people. So often this means that when you ask a scientist a question, something like, "Can you please explain that graph you just showed?" We'll stop and we'll look at you and we'll kind of screw our faces looking at you, and we won't respond right away, and that's really intimidating to a lot of people because you're sort of projecting your grade school teacher onto us, the scientists, and you're thinking that we're thinking something like, "How could you ask such a stupid question?" Right? When really, in reality, scientists are thinking something much more like, "Geez, did I really do such a bad job that nobody understands what I'm trying to say?" And so scientists really, really need help with communication. We have our own language, and it's called jargon. And we use it a lot when we want to sound really impressive. And mostly it makes us sound obtuse. But we don't get that because that's part of that social signal not understanding thing. We really persist in thinking three things. One, that everybody in the world secretly wants to be a scientist. And two, that everybody in the world will be impressed if we use really science-y language. And three, that leading with the head, that is thinking, can solve all of the problems in the world. So let me give you some examples of what I mean, just to bring this down to reality. This is a science communication. And you can see that it's a really easy to understand graphic. And so, when we do things like this in science, we put captions on the graphics, and they look something like this, and you can read those words. And I'm sure that makes a lot of sense to you now. And so I'm going to just translate this for you. Here's the translation of this graphic. Almost no matter how you calculate it, we're losing millions of acres of forests, right? Here's another really great example. On marine habitat degradation and loss, and here is part of the caption of that graphic, really connecting to the main issue here. Here's the translation. There is no untouched place, right? There's no pristine left in the world. Here's one on global loss of marine biodiversity, and this is great. It's got color and a map. So we in science feel very proud of ourselves when we can do stuff like this, and so we put in lots of really big sciencey words like trajectories and best fit power models corrected for temporal autocorrelation. Are you sleeping yet? But here's the translation of that graphic, right? The world's fish and shellfish are going to be extinct by mid-century unless we get off our butts and do something now. And finally, I think I have two more. This is on climate change. back to black and white here. And there's the caption that the scientist put on there. I'm sure you're all extremely familiar with future scenarios IS-92A and S-650. Here's the translation. When we add carbon to the air, it creates more acidic ocean, and the shellfish are literally dissolving. And finally, here's another consequence of going above 360, and I just couldn't resist putting almost all of the caption here. It goes on and on. Honestly, I had to read this for half an hour in order to figure out that, in fact, the translation, and you'll notice there's not a lot of room left on this slide. There's a translation. So, it should be abundantly clear to you now that scientists need translators. And they also need to learn that most people don't act from the head. People act from the gut and from the heart. They respond to feelings and to emotions. They're not motivated by numbers or graphs. They're motivated by images. So the second thing I want to spend a little time on is who we are, who scientists are. Okay, so in my world, and in the public's view of my world, scientists are men, right? This is just going to Google Images and typing in scientists. This is what you get. They're men, except sometimes they're female movie stars. And they are white. And they're old. In fact, they're really old. And some of them are crazy. And they like to wear white lab coats. And they are frequently found in association with microscopes and chemicals. Unless, of course, they are doing math on a chalkboard. And although you might find this amusing, and in some sense it is, in other ways it actually really isn't. So as I stand here today in 2016, 8 years after an African-American president took over and on the cusp of electing the first female president, what I can tell you about science, and conservation science in particular, is that it still largely looks like this picture, albeit with the uniform of the lab coat and the safety glasses replaced by jeans and a plaid shirt and Birkenstocks in conservation. So in my own college, in the College of the Environment at UW, we have about 230 faculty in 7 departments, with fantastic photos taken by Benj and Sarah, thank you. But only 25% of them are women, and only a very small fraction of them are people of color. We have, I'm told, an unbearable whiteness of being in our college. And in fact, that's normal in conservation. Today, just under 80% of the Forest Service is white. It's over 80% in the National Park Service. It's about 90% at the Nature Conservancy. And you can imagine the male to female ratio in all of those places. So it turns out that Google Images might not be that far off after all. And the reason that I bring this up is because it strikes me, and it struck quite a few of us in conservation and in science in general, that our practice, how we do things, how we think, how we choose what to work on, is, like in any other professional discipline, a function of culture. And when the culture of science is dominated by a single race, ethnicity, or gender, well, maybe we're seeing the world in only one way. And I'm going to tell you more about that in a minute. So I want to consider what female scientists, and in particular female scientists working in conservation, look like. And I know one of them because I am one of them. And so here's what I look like in the field, or what I did look like, and what I do. So in 1991, I was a postdoc at the UW, out working on the outer coast of Washington on an island named Tatoosh, which is shown at the bottom of this slide. And I worked on seabirds, common murres, that nested on Tatoosh. And I spent hundreds of hours, thousands of hours, sitting on that cliff right there, working out that kind of tight space arrangement with that very gull, who also lived there, and staring into a spotting scope and into binoculars at murres that were crammed into these little ledges in the vertical cliff wall. And so I wore the uniform, you know, plaid shirt and all, albeit maybe with a pink turtleneck, And I took notes, and I made measurements, and I talked jargon, and I created mathematical models to understand what was going on, all the things a good field ecologist can do. And then one day, in late July, a Chinese freighter steaming into the Strait of Juan de Fuca ran over a Japanese fishing vessel, causing an oil spill that spread from Vancouver Island down the Washington coastline. And I was on the island when this happened, and it was a pretty warm, very foggy day, and the sea was unusually calm. And I was down at the waterline, and I started to hear a really weird noise. And it was as if somebody was slapping the water. And I realized that what I was hearing was the sound of bird wings hitting the water as these birds rode almost in a butterfly stroke and tried to get to shore because they were completely oiled and they needed to get out of the water. And so as I watched, my birds, my mers, came through the fog and crawled out into the intertidal, completely covered with oil. And then I started to smell the oil, and then I knew what was happening. And I knew that thousands, maybe tens of thousands, of birds were going to die because of something that people had done. Not obviously on purpose, but the effect on the mers was the same as if somebody had basically dynamited the colony. And that's the day that I became a conservation biologist, because that was the day that my head stopped working and my heart and my gut took over. And you know, it made me mad. Mad that the spill had happened because the Canadian Coast Guard that had frantically been trying to get in touch with the Chinese freighter couldn't communicate because there was no one who spoke English on the bridge. And mad that the air was very soon full of helicopters, news helicopters and dignitary helicopters and God knows who in helicopters flying over the island and scaring all of the mers on the cliff into the water where the oil was, right? And mad that all of my knowledge and my mathematical models and all of my academic prowess didn't seem very valuable at that point. And mad that there was nothing that I could do. But actually, more about that in a minute, too. So here's how I look now, and thank you, Benj, for making me look great. And I've got to say that I love these photos because they make me look irreverent. And that's how I often feel these days as I try to be a woman in science and a woman in conservation. So one of the big lessons that I've learned is that you have to just be yourself. So I no longer wear the uniform. I wear clothes I like, clothes that suit me, and I don't care whether my colleagues find them appropriate or not. It was once reported in the Seattle Times that I bought my underwear from Victoria's Secrets, which at the time was true. They had really great cotton underwear. That part was left out of the story. And when I came into work at the U the next day, several of my male colleagues informed me in no uncertain terms that my career was over because that statement had come out in the paper. Well, now I am the associate dean. So one of the cool things about gaining that kind of freedom was the thinking that came with it. I stopped trying to be someone else, the quantitative ecologist, someone I thought I was supposed to be, and I started to just be myself. And once I did that, some really interesting things began to happen. I started to wonder whether I could do science differently, whether I could help change the landscape of science. So after that oil spill in 1991, we recovered almost 5,000 bodies, almost all common mers, that washed in along the coastline from Nia Bay to ocean shores. And I wondered, what can I do? So I stood up and I invented a citizen science program called COAST, the Coastal Observation and Seabird Survey Team. COAST is a program that trains people to, in coastal communities, to walk beaches and collect data on beach-cast birds, which is pretty geeked out when you think about it. So we create the baseline against which mortality from an oil spill or a bloom of harmful algae or climate change impacts can be measured. We basically keep the pulse of the system. And we've been extant for about 17 years. Here's a map minus Canada of where we work. We've trained over 3,000 people. Currently, there are 800 people out there from Mendocino in Northern California, all the way on up to Cape Lisburne, which is in the Chukchi Sea, and over to the Commander Islands in Russia. We have found more dead birds than you can shake a stick at, of very, very many different species. And here's how COAST works. We go to people in community and we train them. And we give them all sorts of materials that we make, a field guide, data sheets, and we have a web-based smart data input program. So after you collect the data, you put it into the website. And if you try to put measurements in and then name that species and the measurements don't fit the species, the website will gently say, "Are you sure? Are you sure it's them?" And finally, we verify everything, and we give all of the information back out in all sorts of ways, including our very popular non-denominational holiday card with a dead bird on it every year. No lie, our volunteers love that. So here's the head of how COAST works. We teach evidence first, deduction second. That's the heart of science, right? No guessing, you gotta know. So you work within a framework. Our framework is a dichotomous key, which I'll show you in a minute. So people go out and they look at the foot and they type the foot, and it turns out this is really interesting. You can tell a lot about what bird it is by looking at the foot. It's not something that Sibley is particularly into. That's because it's hard to see the feet of live birds, but it's really easy if they're dead. And then we take standardized measurements, so we teach people how to make standardized measurements. And then, of course, we take photographs, and that's the other really great thing about dead birds. You can pose them, and you can put a ruler in for scale. So we use all of that information, and then we had to create a jargon-free field guide. Now, it's really important when you're thinking about a field guide to take all of those sciencey words out. And the way that we did that was when we were inventing this, we used the grandmother test. We sent the field guide to all of our grandmothers. My grandmother, by the way, is still alive. She's 103. I know, kick butt. And we, with highlighters, and we said, "Grandma, can you just highlight every word that you don't understand or that seems odd or too long to you?" There are a lot of words. And so we went through this quite a lot, and we came up with our field guide, which looks like this. And wonderfully, the Weston Foundation gave us the rights to Edward's photograph for the beginning of this. We now have 3 field guides to the West Coast, to Alaska, to the Northeast. They're translated into multiple languages. It's my best-selling publication. Who knew? And here's what happens when you get people and train them and then get them out there practicing. They're pretty damn accurate. They're really good. And because we can verify all of those species identifications, we can prove that. And that makes the data really useful in science and resource management. And most of those people are not uber birders. In fact, most of those people are not connected to birds at all. They're connected to place. They have a really, really strong sense of place. They love their beach. They don't speak of it as the beach. They speak of it as their beach. And this made me realize that everybody has a place. Everybody has a backyard and several backyards. Everybody is connected to nature in some way. So if you can give them an authentic experience in science and you can bring them in to work not for you but with you, you can really make a difference. And when we ask them why, they tell us. They tell us not only about science and how important science is, they tell us about the collective. So here's a quote from one of our coasters. "Just knowing you are contributing to something that has some value is important, because you've got an organization with almost 1,000 volunteers. The fact is you're able to glean all sorts of information. That makes it purposeful and powerful." We have unwittingly created the Borg, and it's the Borg for good. So I think about who's on the team, right? Who's on the science team? So my team has gone from mine to ours, and now that I know science is a team sport with lots of different positions and all essential. So there are head positions like me, and there are heart and gut positions like all of the coasters, and there are lots and lots of different coasters. So here's what my team looks like. They're not the stale, pale males. in white lab coats. Which is not to say that there aren't men in Coast, of course there are, but there is no dominant, no one type in Coast. We're old and young, we're male and female, we're Democrat and Republican, white and Native American. We're moms and grandmothers and grandsons all surveying together. We're a family. And why does that work? It works because science matters. To me, to Coasters, to all of us, need a head to help direct the heart and gut. So in the early 90s, there was another beach bird program, Adopt a Beach, and they reported dozens of marble merlets washed up on beaches in and around the San Juan Islands. And of course, marble merlets are now, and were then, listed species. So this report created quite a stir. There were calls for immediate shutdown of the local fisheries there, and the state and the feds got involved, and there were lots of letters in the paper, and it was super ugly. And it turns out that the birds weren't merlets. They were mers, which is bad, but not as grave as if they were merlets. So how did this mistake happen? Well, Adopt a Beach didn't use a dichotomous key of dead or live birds, and their volunteers didn't collect measurement evidence, although fortunately they had photographs, which is how we figured out the mistake. They didn't collect foot type, they didn't collect any of the things that Coasters did to rigorously determine species, right? In fact, they just relied on their volunteers to know, to be experts. In other words, they didn't use science. They had a lot of heart and gut, but they didn't have any head. So my world is changing around me pretty darn fast. And I want to make a difference. I want to go past whine about decline. As a scientist, my choice is to use my head in service of the planet and to find people, thousands of people, who are willing to work with me because they're passionate about it or intellectual about it, or simply grateful and awestruck to be on a beach feeling the power of nature and examining the blue feet of a Cassin's auklet or the clown-like bill of a tufted puffin, smelling the gray musk of a fork-tailed storm petrel. You shouldn't miss that. It's fabulous. Or just happy that they can have the experience and confident in the knowledge that they're doing science correctly, that they're making a difference. So here's a plea to you who create amazing, arresting images, who can make us stop and look. Don't use your art in service of only heart and gut. Adopt a scientist. Thank you.